All right, and we are back for another subsection for our research methods course. And in this case, we are talking about uh, experiments that don't meet the requirements for that true experiment label. Right? Remember, there were those 4 requirements for a true experiment. Well, in this section, we're talking about what if one of those isn't possible. Right? So one of the groups we're going to talk about here are pre-experimental research. And pre-experiments, the issue here is we can't have 2 groups for some reason, right? So maybe like climate science. We can't have 2 Earths, one of which we do something to the climate and the other of which we don't. That's physically impossible. If we want to study the pollution in a certain river, we only have the one river. We can't, if we want to introduce something to clean it up or whatever, we can't have an identical river with identical amounts of pollution that doesn't have that method to clean it up, right? So in these cases, we only have the one group, and thus we can't have the random assignment, we can't have the 2 groups, etc., etc. But that doesn't mean we can't do anything. These pre-experiments, they're still useful. They're not quite as useful as the true experiments. They're a little bit harder to draw really firm conclusions from, but they're still useful, and you can still draw a lot of data and a lot of really important stuff from these kind of research designs, right? Now, within this kind of umbrella, there's the one-shot case design, where you just have one group, there's an intervention, and then an observation, right? So maybe we could talk about like fear of terrorism after 9/11, right? So the American people, we lived through 9/11, if you're old enough to have lived through that. And then some researcher says, oh man, I wonder how fear of terrorism has, what fear of terrorism is like right now. So they do a survey asking people about terrorism. That would be a one-shot case design, right? It would more likely, honestly, after having come up with this idea for an example, have been a pre-test, post-test design, because they would have the fear of terrorism surveys from prior to 9/11, right? So in a pre-test, post-test design, you still got the one group, you still got that intervention there, but you have an observation before and you have an observation after, right? So we do a survey about fear of terrorism. Oh wow, now there's a big terrorist attack, so we're going to do this again to see how fear of terrorism has changed, right? Or we have a city and we're tracking its crime rate. And then we pass a new law about hiring and training police officers. And then we do another observation a year later to see if the crime rate has changed, right? That would be a pre-test, post-test design like that, all right? But since there's only one group, it's not a true experiment. But again, sometimes that's a requirement of the situation. Now, quasi-experimental research designs are where we do have more than one group. We have at least 2 groups now, but we don't have that random assignment, right? Random assignment is just impossible for some reason, again, whether legal or ethical or just the nature of reality. We can have more than one group, but we're not able to randomly assign people from one group to the other, right? Now, there's a couple of different ways we can do this here. There's a non-equivalent control group design, which is where essentially, it's just like the that original true experiment we talked about, where it was just 2 groups, an intervention, and then an observation. Very simple like that, except there's no random assignment. So you have people in 2 groups. One of those groups got an intervention, the other didn't. Now we're going to observe. So we go into a prison, and prior to us getting hired, some of those prisoners got a rehabilitation program. Now we're coming in and we're going to see whether the prisoners who went into that rehabilitation program have a lower recidivism rate than the prisoners who didn't go through that rehabilitation program. since we didn't assign prisoners to either get the rehabilitation program or not randomly, we don't have that random assignment into the two groups. This is just kind of a real world, some decision by somebody at the prison split them into two groups, not randomly. But we do still have the two groups. We have the intervention. We can have the observations afterwards. Similarly, a before and after design is the same as the true experiment, where we had the two groups, an initial observation, then the treatment, then another observation afterwards, right? So we've got two groups of police officers. One of them gets a certain type of training. We observe their arrest rates before and after they get this training. But again, if we didn't randomly assign officers to the training or not, we didn't do that random assignment bit. But we can still track and see which of the two groups, the ones that got the new training or the ones that didn't, if there's any change in their arrest rates or, citizen complaints or whatever our dependent variable is, right? Now, the problem there is, with both of these, is any observed difference at the end due to the intervention? Or is it due to the fact that the group who got the treatment was fundamentally different than the group that didn't get the treatment? Because in our prison example, where some prisoners get a rehabilitation program, some prisoners don't, and then we track their recidivism rates afterwards, I'm betting that the prisoners who got the rehabilitation program are the ones who are more well behaved and more willing to kind of follow rules, and thus are less likely to recidivate anyways. And so they're going to have a lower recidivism rate than every other prisoner, not necessarily because of the rehabilitation program, but just based on who they are. That's the problem when you don't have random assignment. It can be very difficult to tell what's actually the effect of the treatment and what's the effect of the fact that the two groups aren't the same to begin with. And it's not impossible to kind of tease those apart and figure out what's actually causal or what's actually due to the treatment and what's not. But it can be very difficult. All right? Now, natural experiments. Natural experiments are the ones that kind of the world gives to you. They're not something you thought to do. They're not something you do on purpose. They're not like, oh, let's specifically go in and introduce this independent variable. It's something that just kind of happened completely without the experimenter's input, right? So one natural experiment might be, 9/11 and fear of terrorism. No researcher said, oh man, I should create a terrorist attack to see how I can affect the fear of terrorism in the world. No. Not only being unethical, that would be, essentially impossible. So, natural experiments are just things that happen in the world, right? So maybe you have two elementary schools in a certain city, and they're very similar, but one of them gets a new principal. And we see whether test scores rise or fall compared to the other elementary school that didn't get a new principal, right? So that control group there gives us a little bit of a counterfactual, because if previously these two schools had been very similar, if one changes and the other doesn't, it's probably due to the one thing that really changed in this example, getting a new principal, right? But natural experiments happen when there's not, it's not a researcher's idea to introduce that treatment. It's just something that happened in the normal course of everyday life, right? Now, there are 4 requirements for causality, right? The easiest, one of the easiest to establish is correlation, right? You change X and Y changes, right? So there's correlation. There's correlation, non-spuriousness, i.e., if X changes and Y changes and they're correlated, let's make sure there isn't some third variable changing both of them, right? Then there's theory, and then there's time order. If you want to say that changes in X cause a change in Y, we have to show that the changes in X happen first in time before change in Y, right? So how do we establish that time order? Well, in some experiments, we do what's called a cross-sectional study, right? And cross-sectional studies are just one point in time. We have this one observation. What do people in the state of Florida think of the Russian invasion of Ukraine? Let's do a thing. That is a one point in time snapshot of reality, right? And if we're doing a study, if we're doing an experiment that only looks at one point in time, how do we establish that time order requirement for causality? Well, one way to do it is when it's fixed, when it's obvious, when it's clear that one thing came first, right? So in my dissertation research, I was looking at age, gender, race, and education level, and its effect on being in prison for a computer crime versus other kinds of crime, right? Well, obviously, kind of by the nature of it, your age, your race, and your gender kind of came earlier in time, if you will. They were dictated prior to you becoming a criminal. So we don't have to establish time order with those three because they're obviously those came first, right? We could also use self-reports, right? So if we want to establish, it's a well-known fact in criminal justice that teens with delinquent peers also commit more delinquency. But is it their delinquency that comes first and they search out delinquent peers? Or is it delinquent peers that come first and that causes them to commit more delinquency? Well, the time order is not so clear. Neither one of those two things is fixed. Neither one of those two things obviously came first, right? So one of the things we do is rely on self-reports. We ask people, hey, what came first? You choosing to do these delinquent things or you hanging out with this group of friends? Another thing we can use is archives, right? We can look at records. We can look at, if it's a medical study, we can go back and look at your health records, right? And then, of course, a control group. If we have a control group, we can look at kind of what happened to these two groups. And if we have an intervention for the experimental group and no intervention for the other group, and then we do an observation afterwards and there's a difference, again, assuming the two groups were the same at the beginning, that kind of establishes that it was the intervention that came first before the change. We can also do what are called longitudinal studies. And these are studies where instead of taking a snapshot in time, we follow things over and over and over and over, right? So there are kind of a few different ways to do this, and I'm going to discuss three. The first is what's called a trend study, or a repeated cross-section. That's where we do a cross-section, then another cross-section, then another cross-section, then another cross-section, right? And polling for elections is very similar, is a good example of this, right? So we don't just, a week before the presidential election, we don't do one poll and say, oh, that's it, we're done. They do polling like weekly each individual polling firm does lots and lots and lots of polling leading up to an election. So they take a sample of Americans, ask them how they're going to vote, and record it. Then a week later, they take another sample of Americans, ask them how they're going to vote, and record it. Then a week later, another sample. So each time they take a new sample of the same population, measure something, and then report it. And using kind of graphing those out with time and who you're going to vote for, we can see whether support for any given political candidate goes up or down or stays the same based on, debates and conventions and all the other things that happen in a presidential campaign. Second thing we can talk about are panel studies. And this is where we draw a sample once, but then do our measurement or observation of that panel many times over time, right? So we might draw a sample of criminals, people in prisons, right? We want to determine their recidivism long term. So we've got this sample of, say, 50 people who are in prison and all got out of prison in the same year. And we're going to observe them every 6 months for the next 5 years to see whether they've gone back to prison or not. But it's the same sample being observed many times. Whereas in the repeated cross-section, it's not every time you do an observation, it's with a new sample from the same population. Right? And then finally, there's a cohort study. Right? And this is where there's it's kind of a combination of the two. There's a group going through some process, and we're going to do kind of a repeated cross-section, but from that same group, right? So let's say we want to know how high school students deal with, marijuana and alcohol over time. So we'll take a sample of freshmen 1 year and ask them about their marijuana and alcohol use at the beginning of the year and the end of the year. Then the next year, we take another sample of freshmen and compare that at the beginning of the year and the end of the year. But we also take a sample of the sophomores, the same cohort we interviewed as freshmen the year prior, right? Then the third year, we take a sample of freshmen, we take a sample of sophomores, we take a sample of juniors. The juniors are the same people, the same group from which we have drawn a sample the first 2 years. Sophomores are the same group that we took a sample of as freshmen the last year, and then the freshmen are the new class that we haven't sampled yet. And with all three of those, we asked them about their use of marijuana and alcohol, right? So in that way, we're able to follow over time the same group, in this case, sorted by graduation year, the same group over time. It's not exactly the same people, but it's the same group that we're sampling over time to see both how drug and alcohol among freshmen is going up or down based on time, but with that same cohort of freshmen from year 1, we want to see how that changes over year 2, over year 3, over year 4, right? So that's a cohort study. All right, that's the end of this section. Thank you so much for watching. I really appreciate it.